What up, my slimes? Today we're talking about chemical bonds. Chemical bonds occur when an element is trying to fill up its valence shell. Now, in order to tell how many electrons an element has in its shell, you count it across the table. Hydrogen is 1, beryllium 2, boron 3, 4, 5, 6, 7, 8. Now, what does this mean? Well, when an element is forming a bond, it's going to either lose or gain an electron. And so, because hydrogen has 1, then it'll always give up its electron, which means that it's +1, beryllium's +2, all these in this column, +3, 0, -3, -2, -1, 0. So, I know you're wondering, what kind of bonds do these electrons form? But first, we need to talk about some more rules. So, in order to tell the electronegativity of an electron, the higher you are, the more electronegative it is, and the further you are to the right, more electronegativity. There are 3 types of bonds: ionic, covalent, and metallic. First, we're going to talk about ionic bonds, which is between a metal and a non-metal. Alright, here we have an ionic compound called sodium chloride, otherwise known as table salt. It's made up of sodium and chlorine. Now, sodium has 1 extra electron in its valence, in its outer shell. It's 1 valence electron. Chlorine has 7 valence electrons. Sodium is going to give up its electron and give it to chlorine so that they both have a full outer shell. Electron is negatively charged, which means if sodium gives up 1, then it becomes +1, and if chlorine takes in 1, it becomes -1, which you can see in the periodic trends: +1 sodium, -1 chlorine. So, an ionic compound is between a metal and a nonmetal. While these nonmetals give you their charges, while these metals give you their charges, these metals don't. However, in the problem it'll tell you, here we have nickel 1 oxide. The 1 means that nickel is +1, and we already know that oxygen is -2, and so it's Ni2O. In ionic compounds, there's something called polyatomic ions. You can see them here in the cheat sheet given by Mr. DeCamp. Now, in this problem, it's aluminum, you find Cl3 chlorate. But why is there 3 outside of it? Well, when you're finding the charge, aluminum is +3, and as you can see on the cheat sheet, ClO3 is minus, so that's -1, which means you need 3 of it to make the charges equal. While covalent compounds are like ionic compounds because they both form chemical bonds, covalent compounds are only between nonmetals, and instead of giving up an electron, the elements share electrons. This is an example of a covalent bond, H2O. Hydrogen has 1 electron in its outer valence and wants 2, while oxygen has 6 in its outer valence and wants to make 8. To do so, 2 hydrogens and an oxygen meet. Right here, the hydrogen bond and the electrons, they share. So at one point, hydrogen will have 2, while at another time, oxygen will have a total of 8. Same thing over here. Hydrogen will have 2 at one point, while oxygen will have a total of 8. Now, you need to know how to name covalent bonds. In order to do that, you have to understand these prefixes. And once you know those, you can come over here into O4. Because there's 2 nitrogen, you use your prefix di, nitrogen, 4 oxygen, tetra, oxide. You notice that it's oxide, not oxygen, because just like in ionic compounds, you drop the ending and add "ide." Now, there is an exception to this. In the first element, if there's only 1 of them, you don't put mononitrogen, you just say nitrogen. Lewis structures are used to determine the amount of electron bonds within a chemical compound and where those bonds are. So, in order to figure it out, you have to find your valence structure. You have to find the number of valence electrons. You add them together. For example, here in oxygen has 6 valence electrons. Hydrogen has 1, hydrogen has 1, which makes 8 valence electrons. You divide that by 2, so you get 4 pairs. Each of these lines counts as 1 pair, and then each of these 2 dots counts as 1 pair, which makes 4 pairs. That's how you build a Lewis-Stock structure. These are all of the examples of different types of Lewis-Stock structures that are possible. H2O is an example of an AX2E2. Metals have 4 properties: good conductors of heat and electricity, high melting point, ductile, and shiny. This is an example of a metallic element. It's called a sea of electrons. It's made up of metal cations surrounded by delocalized electrons. The metallic bonds are strong with a high melting point, but atoms can also slide past each other, which makes it very malleable and allows light to be reflected. I'll catch you later, my slimes. Thanks for watching our chemistry video. See you next time. What's up? It's Davis. Today we're going to be talking about... Those are called diatomic.